let me start by just taking 60 seconds here to introduce myself and the team and what we're doing at Apple. Anandhi joined our team 3 years ago. She's made code contributions to Airflow and has recently driven the development of an eventing system. That's what we're talking about today. That sees tens of millions of events daily and is increasingly a core component of our ecosystem. XD, or Xiaodong, or XD as he prefers, it should be familiar to all of you. He's an Airflow PMC core contributor. He also joined our team about 3 years ago. And along with contributing to open source, he helps lead the Airflow community at Apple. XD has designed a system that enables Airflow to be resource aware and more flexible for the use cases that we see. So we'll talk about that second. And lastly, hi, I'm Roberto. I have the privilege of leading the team at Apple that's responsible for developing and maintaining the different components that are needed for running data pipelines. One of the key components, of course, is Airflow. We support all of the teams at Apple, and we deal with, like I said before, tens of millions of events every day, and we're dealing with hundreds of thousands of tasks every single day. So let me jump into what we're here to talk about. We're going to talk about Airflow, how we made our Airflow installation event and resource aware. We'll talk about how we did this using some external components. And the intention here is to talk about the problems that we faced and the solutions that we came up with, but possibly open this up for discussion to learn more about how other people have solved these problems. So let me start off by just giving you the problems that we've addressed. So when talking to our customers, we found that they were challenged with the overhead of managing their own compute. They needed to be aware of the resource constraints on their compute. They faced challenges coordinating with other users, again, on limited compute. And they were unable to take advantage of multiple compute options. Lastly, they weren't able to define their DAGs in terms of deadlines. A lot of our customers think about when a DAG should complete by, not when it should start or how often it should run, but when it should complete by to make sure they meet their SLOs. With that feedback, our team started working on things. We developed an eventing system and added more dependency checking in Airflow. We'll dive into both of those. And now our users can offload event and resource checking and awareness to the orchestrator and can easily describe their DAGs in terms of deadlines to make sure they meet their SLOs. So with that, I'm going to hand off the mic to Anandhi to dive into the details of how this stuff works.
Thank you, Roberto. Hi, everyone. I'm Anandhi. It's nice to be here with you all today. So you just heard about some of the problems we're trying to solve. Now we'll be looking into how we are doing this. So we built a system called as Event Service, and it's a standalone application that deals with events at scale. Users can set up event-based actions using the subscriptions that we have in Event Service, and they can also use Airflow custom operators to invoke these actions. So let's look into it. So why did we build such a system in the first place? So generally, a data processing ecosystem, it consists of several services, such as Spark, Flink, Trino, Airflow, etc. And each of these services hosts several jobs that run multiple times a day. Okay, and each of these runs come across like different states throughout the day. Managing these services and runs can really get complex. So, can we reduce the number of hops a user has to take to manage these runs? That is what Event Service is trying to address by providing a centralized hub for system events. It provides a single pane of view for users to track states across services. It collects, stores, and distributes events to the interested parties. It decouples system dependencies with a push mechanism. You can imagine a Jupyter notebook triggering a Spark job. There is generally a polling mechanism or a constant log streaming between the parent and the triggered job to sync the status. And if it is a long-running job, you would need large retry numbers to manage some failures related due to the network issues or the pods getting reassigned, those kind of failures. So Event Service addresses these issues with a push mechanism where all you need is an event to convey the status from the triggered job to the parent job. Event Service also has real-time notifications and dashboards, which can enable ops teams to take real-time and quicker actions on some of the job failures. Next, managing dependencies. So a data ecosystem consists of ETLs that have upstream data, that depend on upstream data availability. This involves several data generation jobs, data sources, and data tables. Instead of having a DAG that is scheduled at a certain frequency and looking for or polling for the data availability, we have come up with event-based workflow orchestration that minimizes this retries or the constant polling mechanism. This brings the advantage of event-efficient state-based triggers, lowers latency or just-in-time scheduling, and most importantly, avoids resource wastage. Moving on to our architecture. So on the left, you can see certain services that are publishing events to the centralized control plane, which is the event service. We also have data engineering jobs that can publish the status of the data readiness to event service. We have created some custom operators in Airflow, starting with the publish operator, which users can use to publish events from an intermediate step in their DAG. These events are collected and stored in event service, and they're available for read in various ways, such as starting with event sensor. This is again a custom sensor that is built in Airflow to read events. This helps you to bring in external dependencies into your DAG. Also, event service enables SLO and event orchestration. XD from our team, he'll be talking more about it in a bit. Event service can also trigger DAGs based on the events being met. We also have a notifier that can send notifications to the end users. The most powerful one being the webhook, because it helps you to transition the states between systems. So we are also aware of Airflow's data-aware scheduling. Though it meets many of our use cases, there are some limitations too. Starting with something like handling dependencies, data-aware scheduling is closely tied to dataset readiness. However, event service is multi-purpose. It can handle events related to SLA misses, job errors, or even an optimization report. Coming to the standalone nature, data-aware scheduling is tightly coupled to Airflow. The actions you want to take should be a task in Airflow. However, event service, it supports external events and also can trigger actions in external systems. Isolation. So the data-aware scheduling, it closely ties to the instance, the Airflow instance. So generally, in a company or something like that, teams might prefer isolated Airflow environments. So in such cases, having the data set event in multiple Airflow instances might not be efficient. However, event service is centralized, and it comes with publish once and read from anywhere. Coming to the scalability, it could be limited by the capacity of that particular Airflow cluster. However, event service is designed for scale. Traceability. So Airflow provides amazing traceability view for data-aware scheduling by giving the view of the dataset readiness at your pipeline level. And it also gives a very good lineage view for the datasets. This is still work in progress in event service. So thank you. And over to XD to talk about SNO orchestration.
Thanks, Roberto and Anandhi. So now I will talk more details about the resource awareness and SLO orchestration, right? So I think just now Roberto already briefly shared the idea, but maybe I will give some examples. Resource awareness, say if I have a lot of jobs, all of them need GPU resource. But when Airflow schedules a job, most likely it will not be able to know, okay, what is the availability of my GPU resource, right? Then if it just schedules all these jobs as normal, then you can imagine maybe some of them cannot get the resource, right? Of course, it's fine because Airflow will retry later, but that is not most efficient, right? And with SLO orchestration, actually there is a question very, very valuable in my opinion. So because now in Airflow, most of the time, we are specifying a schedule, right? Cron expiration, I say this job should start at 9 a.m. this morning, or maybe it will be triggered by your events, right? Or let's say the data set. But sometimes it doesn't matter because maybe I don't care when this job starts. I only care when this job can complete. I have certain deadlines for this job. As long as it can finish by this timeline, it is fine. It's just like you are the investors and I am the portfolio manager, right? I come to you and say, hey, later I'm going to buy this stock, 1,000 stocks. Later I'm going to sell all of them. Tomorrow what am I going to do? How will you feel? You will tell me, no, go away, because I don't care. What you care is, in the end, how much money I can make for you, right? The same for Airflow, because maybe sometimes the user don't care when it starts, they only care when it ends, right? So that is what we mean by SOO orchestration, right? So somehow, what we want to implement is like driving. So sometimes you go to some intersections, you have to stop, watch around to see if there's anything around, right? Maybe something happening 20 meters in front of you, or maybe someone is crossing the street, right? I can also give you another example. So because I fly paraglider, so 3 days ago on Sunday, I'm flying somewhere less than 100 kilometers from here. I was launching, I was preparing to run, right, so that I can get lifted by the air. I felt something wrong with my right hand. The line is somehow stuck, not so smooth. I thought it's fine, because sometimes there is some grass, some branch stuck there, right? Once you get lifted by air, it will be good. But actually, that was a line, as the line got tangled. I launched, but actually I couldn't control myself. I somehow crashed. Not serious, okay, but actually I bruised my leg. Even if now there is still some pad here. So, but that's fine, right? I repack, re-prepare, I go to launch again, I enjoyed the time in the air, but maybe I could avoid that, right? The same here. If I just stop and check and ensure everything is okay, that will be better. That is more efficient, right? So Airflow already does this all the time, right? Because in Airflow, it has a lot of dependency checks. So here you can see there are some categories, right? Airflow checks some dependencies to see if the job or the diagram is ready to be queued, or if the task instance is ready to be running, or there are some dependency checks for backfill, right? And if you dive deeper, you will see there are a lot of checks. Some of them are checking if there is enough slot, or if the concurrency configuration allows this task to start. Something like that, right? Or something else, like if the state is valid, a lot of them. So a very natural thought we would have is it possible that we can just add some custom dependency check, right? Depending on my use case, my infrastructure, I can add some extra dependency check here. So Airflow itself can help me do that stop and check thing to make the whole thing safer, more efficient, right? So the idea here is if we can specify a custom dependency check and add that into the correct place in the schedule code. For our case, possibly that is this method called diagram.taskInstance scheduling decisions, because maybe I care about all the dependencies or conditions for certain tasks. Then if I can specify a custom dependency check, then ensure it is being checked there, then I'm going to have a much, much stronger control on the scheduling, right? Depending on my use case, my infrastructure, or whatever random requirements from my user, right? Sometimes it's crazy requirements or requests. I can just add them here. So this sounds a great idea. So actually we prepared a pull request, like at least a draft. We proposed this to the community back in this year's February, right? So there were some discussions and I got some really, really valuable feedback from the community. Pros is, of course, we're going to have a more flexible and more customized scheduling. But what is the cons? You are going to run this code, your custom code in the very center of the scheduling, which is very risky, right? Because if it's not performant or there is some security issue, that will just be a big problem. But we still have to move on. So in our current implementation, we're doing that in the pod mutation hook because we use Kubernetes executor, right? So what we do is in the pod mutation hook, we could write the code to check all the dependencies like event dependencies, or I want to check some certain stuff, like if this task is really, really ready to run, or if it's an optimal time to run, right? This is not perfect ideal because we don't want it to be pod mutation hook. There is no, let's say, fixed template, no fixed practice to do that, but this is a solution we're doing now. Then what can we achieve using this, right? So there are a lot of possibilities, and here I'm just listing a few of them. The first, integrate with event service, because in this case, I can just specify different dependencies, event dependencies for a certain task instance. And only when all the conditions or dependencies are met according to the event service, I will say, okay, now this task instance is good to go, right? And second, resource availability check. For our case, because we get the quota by namespace. So what we can do is, the task will try using the resource in namespace 1, it's okay, then it go ahead. But maybe namespace 1 is busy, there is no enough resource. Actually, our code is able to help fall back to a different namespace because it's just updating the pod manifest, right? So that's something it can do for us. And this idea definitely applies to other resource type of problem as well. For example, the GPU I mentioned just now. You can do the check here, actually. GPU, right, I can check if I have enough resource. If not, don't do anything, right? Just fail this pod creation process, and the scheduler will just retry later. And so it's a consciously retry, right? So in this case, all these tasks will not compete and at the same time for the limited resource because some of them will definitely fail. That is not the most ideal way to arrange all this. Last one, smarter scheduling. This is most interesting because this is addressing that valuable question I mentioned just now. Because in this case, you can imagine now all the tasks always get executed according to what we want them to, right? Say the schedule interval, or let's say the dataset update events. But as I mentioned just now, sometimes we don't really care because if I have thousands of jobs at the same time, let's say to run this morning, I really don't care when they start. Of course, starting on time is great, but what I really care is globally if all of them can meet their deadline timeline. And think about this, if I really have limited resource, I know not all of them can meet the timeline, then actually there is an, let's say, optimization objective. That is to ensure as many jobs as possible that can meet the timeline, right? So we have something to optimize instead of only depending on the schedule interval, dataset updates, or the priority weight, right? That is what Airflow has. But if we can make this even smarter, so because this becomes a very typical linear optimization problem. If you measure in math, that is something you learn in the first year of the university, right? Then it becomes a very typical linear optimization problem because given the limited resource and all the job manifest, you can just reorder them instead of only depending on the scheduling tool, right? So that is what we mean by smarter in scheduling. Of course, I'm not trying to say Airflow itself is not smart. It's a great tool, right? But by using this feature, I think we can just make it even more flexible and useful. So that is what we mean by smarter scheduling. So there are two things I would like everyone to take back and think, and if possible, share some feedback. First is, what do you think you can do using this stop and check idea? Here we're talking about event dependency, resource check, and more, let's say, smarter scheduling. This one can be let's say, based on certain algorithm. Here I'm just mentioning the idea, right? But how this linear optimization is going to be done, that is up to your algorithm, your model, or it can be something external. So, but the idea is this one. And the second question is what I mentioned just now, that valuable question. Because so far we only think about, okay, if this job can start on time, if it can respond as timely as possible, right? When the data set upstream has changed, it has been updated, right? But is that really the most optimal optimization objective? Maybe not, right? There may be some other function that we can optimize, for example, based on the timeline. Of course, this will require extra inputs. For example, for my task, what is the duration? What is the timeline, right? All these are the additional information we need from the user. But maybe the duration that can be summarized from the history. But that is something I think I will encourage everyone to think of, and possibly that can be something in the future version of Airflow. Instead of specifying the schedule interval, we can make it even smarter because this can help us achieve, according to me, I prefer to call it that globally optimized scheduling, right? So that is something I will encourage everyone to think. I mean, I would like to pick something from your brain, pick a brain, and to help me think how this can work better. So I would really appreciate some feedback, no matter later after this presentation or later in this online. But I think that is everything we would like to share here for this presentation. Thank you so much.